Hello everyone. Today inshallah we will continue with our lectures. We're still in chapter 3 and we will go today for the chain rule, the homogeneity, and for Taylor formula, Taylor expansion or Taylor polynomials in order to expand certain functions. Of course, all of our course notes and references, you will find them on Moodle, and the recorded lectures, you will find them on the YouTube. Also, I sent you earlier this week most of the PDFs that will be covered today, inshallah. I'm not really sure if the PDF of this lecture was sent to you or not. Please do check, and after the lecture, I can send you the PDF on the WhatsApp also, if there is no problem. Okay, let's start with the chain theory. As I told you for the agenda of today, we will go through chain rule in multi-variable functions or functions several variables. Then we will go through homogeneous functions and the homogeneity degree. Then finally we will go through Taylor expansion either in one dimension to remember the stuff. Then we will go to multi-variable functions. Multi-variable functions also, inshallah. Okay, let's start our discussion with the chain theory. As I was telling you, the chain theory is really very simple rule. It's usually applicable if you have a function like h, which is a composite function min, which means f is composite x, okay? And I need to differentiate h, but with respect to t. It's really very simple, and the name came from the chain reaction that you will see. So simply, if I want to get dh by dt, all I have to do is to first differentiate h with respect to its variables. So it's gonna be partial h, partial x, then I will differentiate x with respect to t, so I will multiply by dx by dt. Since we are talking about function in one variable, then we will deal with total derivative. So it's gonna be dh by dx. If you remark, it's a differentiation for h with respect to its component. So the first thing, I will differentiate h with respect to x times differentiation of x with respect to dt. Usually, Omar, it's like cancelling these two guys together. You will find dh over dt, as you can see. It's very, very simple. As I told you, the rule is simple, but all you need is just to focus, and then you will be able to see the rule. It's really very simple. Thank you. Here it is the differentiable function of t and its derivative. So as I told you, the first step is to get dh by dt, then dh by dx, then you multiply by the remaining of the rule, as you can see. This is also, if I change the name of the function, so it's going to be dz by dt. It's going to be df by dx times dx by dt. It's going to be the same case. As I told you, it's explaining that f is a function in x and x is a function in t, as you can see. Let's see if for this problem, you have here, he wants you to find dh by dt for the function h, which means f composite x, or f of x and the x of t, and the x is a function in t, as you can see. So all I have to do, it's very, very simple steps. Be sure about the number of variables that you are dealing with. The function h is just only a function in one variable, which is x. And x by itself is just a function in also one variable. In this case, I will use, Mr. Ahmed, the general case of this rule. So it's gonna be dh by dt, which is simply gonna be dh with respect to its main variable, which is dx, times dx by dt. I will start from here. I will start considering this is h, and I will start differentiating. Let's differentiate. Once more, I will differentiate 3x squared, which is gonna be 6x, plus the derivative of sine of 2x, which is gonna be, sine 2x is gonna be, cosine 2 of an x, then times derivative, what? The argument, which means it's time 2. This is the derivative of h with respect to x. Then I will put the junction connecting x with respect to t, which means I will multiply by dx over dt. So this is the part that contains x and t relationship. Differentiate with respect to t, so it's gonna be times 3. Final, I will substitute instead of x in each part by its main value, which is 3t plus 1. So you will have 6 times 3t plus 1 plus 2 times cosine over 2 times 3t plus 1. Start simplifying everything, and don't forget all of this value is already multiplied by 3. Then start simplifying other terms and simplify this expression. As I told you, in a similar manner, we can do exactly the same. Once more, look, if I want to find dh by dt, I will multiply df by dx times dx by dt. So all I have to do is differentiate this guy, which is going to be 6 of x plus 2 cosine 2x, times derivative with respect to t, which is going to be 3. After differentiation, start substituting instead of x by the value, which is 3t by plus 1. So this is the final result for this problem. In a similar manner, you can find plenty of problems like this one too. He wants you to find same way like dh by dt for the function which is given h as a function in x and the x as a function in t, as you can see. So it's exactly the same rule. Once more, I will have to be sure about the variables. As you can see, that's this function, which is x, is a function just only, or h, or the name of f, is h of x is just only a function in one variable, and even this variable is function in just only one another variable. In this case, I will use the rule without partial fraction, but partial derivatives. So once more, all I have to do is to get, as I told you, dh by dt. If you like to use this symbol, it's okay. If you like to change it to be dh by dt, as usually I do, times dx by dt, it's okay too. It's really up to you. So all I have to do once more is to differentiate this part, which is gonna be e to the power of x plus 2 of an x. Then I will have to deal with this guy, which is dx by dt, it's gonna be 2. Then I will multiply them together and substitute. It's really very simple. So once more, here we go. This is dh by dt, which is gonna be df by dx times dx by dt. Okay, df by dx, it will come from here, which is gonna be e to the power of x plus 2 over x, times dx by dt, which is gonna come from this part, which is gonna be 2. This is why you can see 2. The final step, I will substitute instead of x by the value 2t, which leaves you with e to the power of 2t plus 4t, all of them times 2, and that's the solution of this problem. As you can see, it's very, very simple. This is the rule if you are doing a total derivative, as you can see. As h is a function in just only one variable, and same way like the inner function is also a function in one variable. Okay, functions in several variables. In this case, I will have plenty of cases. The first case of them, as you can see, the main function is a function in x and y. But both x and y are functions in the same variable, and they are in just only one variable. So once more, the main governing function is a function in more than one variable. But the inner functions are functions in just only one variable. So if I want to get, in this case, if I want to have dh by dt, I will have to do the following. I will have to differentiate first h with respect to its variables. And as you can see, h is a function in x of t and y of t. So all I have to do is to first get partial f partial x, then plus partial f partial y. Omar, pay attention please. So the first step, all I have to do is to differentiate the function with respect to its variables. As h is a function in x and y, so this is why I have differentiated with respect to x, then added the derivative with respect to y. The second step, both of x and y are functions in one variable. Both of them are functions in t. So what I do, Mr. Ahmed, is to multiply by dx by dt. This guy also will be dx by dt. If you remark, the first two derivatives are partial derivatives. And you know the reason, because their main function is a function more than one variable. But the second derivative is a total derivative, because x is just only a function in t and y is a function in t. Okay? I can explain this by the tree diagram. Okay? You will find it here. I've already have it in the slides. So it's gonna be, as I told you exactly. This is how it is written. So partial f partial x dx by dt, partial f partial y dy by dt. If you remark, this is f, which depends on two variables and two main functions, and each of these two functions is a function in just only one variable. It's really very good idea to look to the tree diagram that explains the relation between the main function and the inner function, as you can see. Okay. The second step will be a direct substitution with no effort whatsoever. I will start substituting. So, whatever depends on the problem, we will see an example shortly, of course. Okay. Also, this rule can be generalized, which means if I have h as a function in x, y, z, and so on, I can differentiate first with respect to the partial derivatives for the function in its variables, then having the total derivative for the remaining of the variables. This is what is explained here. Mr. Ahmed, this is f, which is a function in x1, x2, up to xn. So I will start by differentiating this function with respect to its variables. So I will have partial f partial x1 plus partial f partial x2 plus partial f plus partial x3 and so on. Each one of them will be multiplied by dx1 by dt, then dx2 by dt, dx3 by dt, and so on. So it's just a generalization of this rule. This is the sum, as I told you, of the substitution. But طبعا in short expression using the summation notation. Let's see a couple of problems on this one, like this problem, for example. So the first step, as I told you, Mr. Hussein, if you look, you will find that f consists of how many variables? Two of them, x and y. While x is given as a function in t, and y is given as a function in t. So the first step, without memorizing anything, just to memorize, I will differentiate each function with respect to its own variables. So I can do it really very easily. So if you want to have dh by dt, if I want to have dh by dt, I will have first to differentiate h with respect to its main variables. So it's gonna be partial f or partial h, it's the same, partial x plus partial f partial y. So this part will come from this the first component of your function. Then I will multiply by dx by dt, then multiply by dy by dt. So simply, if we start differentiating f with respect to x, this is just only the first part that will be differentiated. It's gonna lead to 3 times y, then times dx by dt. Where is the x? Here is the x. Differentiate with respect to et, it's gonna be e to the power of t. Then plus partial f partial y. So I will start differentiating this main function with respect to y. Once you start differentiating with respect to y, you will have your 3x minus 2 over y. So differentiating y will leave you 3x, and the minus y squared is going to be negative 2y. All of this will be multiplied by dy by dt. So this is the part that contains the relation between y and t. Differentiating, it's going to be 1 over t, as you can see. The coming step is to make a substitution, replacing every x by its value and every y by its value. So Mr. Muhammad, it's very simple. It's going to be equal to 3. I will replace every y by ln t. So it's going to be 3 ln t times e to the power of t plus, open your bracket, 3. Then I will hit x, which is e to the power of t. E to the power of t. Minus 2, I will replace y by ln over t, and all of this is multiplied by 1 over t, as you can see. It's really very simple. But you have to know from where you are standing, because the cases will be different each time. So once more, if I want to do this, it's really very simple, as I told you. Just identify the number of variables, and then the chain rule is really very simple. So once more, this is dh by dt. It's going to equal to partial f partial x partial f partial y, then times dx by dt times dy by dt. It's a direct substitution, exactly like what we did. Then replacing y by ln t and x by e t, as you can see. That's another problem. Same thing. If you remark that I want to find dh by dt. I want to find dh by dt. Okay, it's exactly the same. I will start by differentiating f first with respect to its own variables. So I will start differentiating this function with respect to x, with respect to y. Then with respect to x will be multiplied by dx by dt, which comes from this relation connecting x and t. For the part with partial y, partial t, it will be multiplied by dy by dt, which will come out of this part. So once more, this is the composition. So dh by dt is going to equal to df by dx, df by dy. This is going to be multiplied by dx over dt, and this one to dy with respect to t. Direct substitution. We're still, in this case, having f as a function in several variables, but each one of them is just only a single valued function in one variable, as you can see. So the next step is just derivative and then substitution. Be careful from the derivative and be aware of the substitution, and then finalize everything by replacing x and y by their values, as you can see. It's really very simple. Okay, once more, let's walk to case number 2. So I have case number 1, which contains a function, single valued function, and the inner function is also a single valued function. Case number 2, the outer function, ya Omar, it's a function in several variables, while each one of these variables, or of each interior functions, is a function in one variable by itself. This case number 2 that we are going to deal with at the time being, you will see functions where the main function is a function in several variables, and the inner function by itself, is a function in more than one variable. In this case, you will have f, and I want you to remark this scheme, you will have f as a function in more than one variable. This is y, and that's x, and then x by itself is a function in s and t, y by itself is a function in s and t. The issue is if I want to find the derivative with respect to s or with respect to t. Of course, in this case, I'm not going to have total derivative. I will have partial derivatives. So once more, okay, In this case, I will differentiate the main function with respect to its variables. Then I will do the link between this variable and the chosen variable with respect to the main function. So I can differentiate h with respect to s or h with respect to t. In each case of them, if you remark, the derivative of partial f, partial x, partial a, partial y already exists in here, but the difference, here I will differentiate x with respect to s, but here I will differentiate x with respect to t, as you can see. That's the shape. I think this is much easier with the colors and everything. Okay, let's see a problem according to this. If I want to look to this problem, you will have f as a function in how many variables? X and y. And even x is a function in how many variables? More than one variable. So actually, this is x, which is a function in s plus 2t, and this is y, which is a function in s squared minus ln t. So if I want to find partial, okay, f partial s, all I have to do, first I will have to differentiate f with respect to its own variables. So it's gonna be partial f partial x, then plus partial f partial y. This is the first step. The second step, you need the derivative to be with respect to mean to s. So I will put the link. I will start differentiating times partial x partial s times partial y partial s, and that's the derivative of this function with respect to the value of s. Now, if I want to have the derivative with respect to t, what to do? Exactly the same. So it's gonna be partial f partial t. عمر خليك معايا. partial f partial x, then plus partial f partial y. Then I will multiply. You need it to be with respect to t. So I will differentiate partial x partial t partial y partial t. Then start substituting. I will start substituting, replacing every one of them by the results that I have. So the first is partial f partial x. I will differentiate this function with respect to x, which is gonna be a 2 of an x. That's the first one. That's the first part. Plus a derivative of f with respect to y. So I will differentiate this guy, which is gonna be 3. Then I will multiply. Partial x, partial s. So from here, I will differentiate this part with respect to s, which is gonna be positive 1. And then replace differentiating y with respect to x, to s. So it's gonna be a 2 of an s. Then I will start writing them together. So it's gonna be a 2 of an x plus 3 times 2, which is 6 of s. Then replace x by its values, which is s plus 2t. I will start replacing x by s plus a 2 of a t. So it's gonna come up to 2 times s plus 6x. It's gonna be 8 of an s. Then 2 times 2t, I believe it's gonna be 40. That's the first one. The second one, similar to the first. Differentiation with respect to x, with respect to f, already exist. Those derivatives already exist. So it's gonna be 2 of an x, then plus, same way like, it's gonna be 3. The difference will be within the derivative of a y. I will with the derivative of t. I will differentiate x with respect to t. So this guy will be differentiated with respect to t. So the result will be 2. And the other one, or the remaining, is going to be differentiated with respect to t. So it's going to be a negative of a 1 over t. Then finalize it exactly like before. It's going to be a 4 over an x minus 3 over t. Then start replacing x by the value of s plus 2t and then add them together, as you can see. This is really a very simple way in order to evaluate your partial derivatives in case you have composite functions, as you can see. Let's do it once more. So, as I told you, and once more, he wants you to find f composite g of s and t with respect to s. Of course, f composite g, which is the derivative of f with respect to t. And he wants you to find f composite g and s of t, as you can see. So all I have to do is to differentiate first f with respect to its own variables. We call this part as z, if you like. If not, write it the way I did, which is much simpler. Partial z, partial x, then partial z, partial y, then multiply partial x, partial s, partial s, partial y, partial s, and start substituting exactly like what we did. I believe we have 8s plus 40. Similar manner, if you remark, this is the first to do derivatives with which they are the same. The difference will be with differentiating with respect to t instead of s, and so the substitution will be, as you can see, 4x plus 8t minus 3 over t. Also, for this problem, he wants you to find the partial derivatives of z with respect to x and y, while he is giving you z, which is a function in u squared plus 3v, while u is a function in x squared plus y, and the v is a function in xy plus ey. He wants you to find partial z, partial x. I can do it directly, once more. As you remark, the main function is a function in how many variables? In two variables, which are u and v. And each of the u and v is a function in how many variables? Two variables. So I will need partial derivatives. So if I want to evaluate partial z, partial x, all I have to do once more, you don't have to memorize anything. Partial z, partial u, plus partial z, partial v. Then you need it with respect to x. So I will multiply partial u, partial of x, partial v, partial of x. It's really very simple, very smooth. Then I will start substituting. I will differentiate first z with respect to u. If I differentiated z with respect to u, it's gonna be just only 2u. Then I will differentiate z with respect to v, which is gonna come up to just only 3 times and times. I will differentiate u with respect to x from here. U with respect to x, it's gonna be 2 over x. Then I will differentiate v with respect to x, which is gonna come up to y. That's the first derivative. Can continue. If I want to find, once more, partial z, partial y. So I will have to find partial z, partial u, plus partial z, partial v. Then I will multiply by partial v, partial y, partial v, partial y, as you can see. It's really, partial u, partial y, then times partial v, partial y. The most important thing is to know, is it case number 1, is it case number 2, and if it is, how I'm going to write, then substitute directly. It's really very simple. Also in a similar manner, if you remark partial z, partial u, partial z, partial v, it's gonna be 2u and 3. Then I will replace this guy by the derivative of this function with respect to y, which is 1. Then differentiation with respect to y, it will leave you with x plus e to the power of y for this guy. Then finally, I can replace u by its value, and if I have v's, I will change them with respect to its variables in x and y, as you can see. Just give me a second. Okay. So here we go once more, partial z, partial f. Partial z, partial x. It's gonna be partial f, partial u, partial f, partial v times partial u, partial x, partial v, partial x. Direct substitution by each one of them. This is the total formula. So substituting, then finally replace u by x square y and replace v if it is exists by the value of x times y to the power of ey. This is the final result for your derivative. Okay. Type. Case number 2, functions with several variables. These are the cases, and also that's another problem in a similar manner. As you can see, this is x as an s of t, and this is the value of x as a function st and y as a function of s over t. I need to find the derivative partial f, partial s. So in a similar manner, I will differentiate first f with respect to x and y, then times partial x, partial s, partial y, partial s, as you can see. Direct substitution with the given functions. The first of them is to find the derivative. Let me do it with you. The first, I need to find the derivative of f with respect to x. So I will get it from here. Differentiate with respect to x. Any ideas? Mr. Hussein, differentiate with respect to x. It's gonna be the exponential function, which is e to the power of x squared plus y, times the derivative of the power, which is 2x. All of this will be multiplied by d partial x, partial s. This is partial x, partial s, which means it's going to be multiplied by t. Then plus. Differentiate with respect to y. I'll differentiate this guy with respect to y. So it's going to be the exponential function, which is e squared plus y, times the derivative of the power with respect to y, which is 1. Then I will multiply by partial y, partial s, which is going to come from here, which is going to be 1 over t, as you can see. Then I will start resubstituting once more. Instead of x, I will put s times t. Instead of y, I will put s over t in all of them. Okay? It's really very simple, very direct. But as I told you, you need to memorize the substitution, the derivative, and the substitution. So this is once more 2x times e to the power of x squared plus y times t. This is e to the power of x squared y times 1 over t once more. Then I will, of course, there is a typo here. This is x squared plus y. So, okay, this is x squared plus y, not x squared times y. As you can see, this is plus, so the result will stay the same. Then start substituting. As I told you, it's a typo just in here, but it is corrected in here, so there is no problem whatsoever. Okay? So this is the final answer. If I want to find partial h, partial t, remark that the first two parts are exactly the same. The difference only will be in differentiating x with respect to t, differentiating y with respect to t, as you can see, then in the substitution. It's very, very simple, and I've brought plenty of problems for you in order to make your life easier. Please try to resolve them once more. If you look at these problems, just by a look, it's going to be very, very simple. Try to write them on your own way or using your pen. It's not going to be that easy. Okay? So, once more, it's really very important for you to rewrite them as I told you. Okay. The chain rule generalizes to formulas with 3 or more variables. I think I put one of the problems here, for example, you have x squared, y squared, or no, it's just only of 2 variables. I think I have another problem with more than 1 variable. I still remember this. So this is f in x squared, y squared, while x is a function in s and t, and y in t, just only t. So for this problem, for example, I can write it as the following. This is going to equal to partial f partial x plus partial f partial y. But this guy is times dy by dt, since it is just only a function in t. This one, I will have to, I'm sorry, partial y, partial, he wants to be with respect to t, so it's going to be with respect to t. Okay, but this one is going to be partial x, partial t, as you can see. If I want to make the derivative partial h, partial s, in this case, I will do partial f, partial x times partial x, partial s, then plus partial f, partial y, and the derivative for y with respect to s is gonna come up to 0. So all of this part will be cancelled, and I will have just only the first part, as you can see. Hi, Mr. Muhammad. Okay. So once more, if I want to make substitution, it's gonna be really very simple, as you will see. So here we go. This is partial f, partial x times partial x, partial t. Then df by dy times partial y, partial t. Just a general substitution, and you will have your final result. Then don't forget that I will substitute instead of x by s over t, and instead of each y by ln t to the power of 2. Same way for the other problem, and that's the case. If I'm differentiating with respect to x, as I told you, this is going to be 0. So all of this part will be cancelled, and you will have just only partial f, partial x equal times partial x, partial s. In a direct substitution, it's going to be exactly the same. طيب, let's look to this problem. This is what I was telling you. Now you have that h or f is a function in how many variables? 3 variables. And each one of x and y are functions in how many variables? In 2 variables. So for example, if I need to find partial f, partial t, okay, it's really very simple. All I have to do is to get partial f, partial x, then plus partial f, partial y, then plus partial f, partial z. This is the first step, differentiating f with respect to its own variables. Then I will drive my derivative with respect to the chosen variable. So I will multiply times partial x, partial t, partial y, partial t, partial z, partial t, as you can see. The main derivatives, the black ones, will come from the main function. So simply it's gonna be 1, then plus differentiating with respect to y